Hello and welcome back. This video will be on section 1.3 on collecting sample data. So to begin with, let's look at a couple of definitions, and this will be looking at the difference between an experiment and an observational study. An experiment is when you, as the researcher, will modify something and record what happens after that modification. So you are actively involved in doing something to something and seeing what happens. In an observational study, this is much more hands-off, and these observations and measurements are made without interfering with whatever is being studied. So for instance, an observational study might be going out into the ocean and counting a number of whales. Maybe using a pair of binoculars or an underwater microphone. Here, you are not actually going out and modifying the whales in any way. You are just counting them. This is just an observation. This is just an observational study. Whereas an experiment might be, say, in a medical experiment, might be actively testing different medicine by giving subjects the medicine and seeing the results. In giving them the medicine, you are modifying them and looking to see what happens. Experimental units is sort of the technical term for what is being tested, but we'll call people subjects in an experiment rather than units. One reason why we might want to have an experiment rather than an observational study are what are called lurking variables. So as an example, ice sails go up a lot when the number of drownings will increase. And a researcher might look at this and go, oh, maybe ice sails are causing drownings. Maybe the more people that buy ice, the more drowning there is. But in hindsight, if we look back at this and we go, well, most drownings will happen during the summer when more people are in the water and more people buy ice during the summer. So these lurking variables are just these hidden variables that will influence both things being studied, both things being compared. So an experiment will try to eliminate any outside variable and will try to isolate exactly what you're trying to study. In observational study, there may be outside factors affecting what it is you're observing. So experiments are in general a little bit nicer, but maybe not reasonable given the circumstances. So what makes an experiment good? Or what makes an experiment better than another one? The first one that we want to look at is reproducibility. So if you are going to conduct an experiment and you want other people to trust the results that you come up with, your experiment should be reproducible, meaning other people should be able to conduct the same or similar experiment and to draw the same conclusions that you do. If you can't reproduce your experiment, maybe what you got was simply a fluke. And this has been a big push recently in almost all areas of science, in particular, say, biology and medicine, to ensure that the experiments that define their fields are reproducible. Quite a few have been discovered to not be reproducible, so various areas have had to go back and be restudied now. Another type of experiment that is essential are blind studies. In an experiment, particularly in a medical experiment, the patients, the subjects, will be split into two groups. One will receive the actual treatment, and another will receive a placebo. This is so that you can study the difference between people that receive the treatment to see if they actually improve, as opposed to someone who doesn't receive any treatment at all. However, being told that you are receiving treatment and that you are not receiving treatment will make a difference in your body. The placebo effect essentially means that people that are told that they are receiving treatment will respond in some way. So in order to make sure that the experiment is uniform, you tell everyone that they're receiving a treatment, and even though some of them will only be receiving a placebo. Or you inform them that some people will be receiving treatments and some people will be receiving placebos. But the point is, you don't tell people which one they get. This is what's blind in a blind study. The subject isn't aware of whether or not they're receiving treatments or placebos to try to mitigate any effects of sort of positive beliefs in their medicine. Now, you can also have a double-blind study. So in a blind study, it's just the subjects that are blind as to whether or not they're receiving treatment. In a double-blind study, the researchers themselves don't know who is receiving the treatment and who isn't. And this is because if you are aware that someone is receiving a placebo or someone is receiving the actual treatment, you may treat them differently subconsciously. You may not believe them if they're receiving a placebo when they feel that they're getting better. And your doubt in that may cast doubt onto them. So in a double-blind study, in order to prevent any accidental revealing of whether or not they're receiving treatment, the researchers themselves are unaware of who's whom. Now, clearly they have to keep track of who's received the treatment and who's received the placebo, but they'll maybe seal it away until the end of the study, when they can actually go back and analyze the results. And then the last one is randomization. And realistically, when you are randomizing a study, what you're trying to do is make sure that any group that's tested is going to be similar. So when you're splitting up people between the treatment and the placebo in, say, a medical study, you want these groups to be roughly similar, so you may randomly select them. This was a big problem for early psychology studies, say in the early 1900s, when many researchers would randomly select students at universities. Now, at the time, most students at universities were white males in their early 20s and came from wealthy families. So their subjects weren't exactly random, and thus a lot of early psychology studies are not very valid because they don't study a truly random portion of the population. So when you are selecting a sample, there are multiple ways to do this. And one way is to truly make it random, as in you put everyone's name into a hat and you draw out how many you need. If you need N people for your study, you'll just pick N names. And the word simple here, a simple random sample, is when literally every set of N people that you could possibly choose are equally weighted, as in they're equally likely to be selected as part of a group. This isn't always possible. For instance, if you were going to conduct a medical study in the US and you wanted a simple random sample of American citizens, it would be hard to take and find a truly random sample of, say, 500 of the 300 million Americans. So other approaches may be more practical. For instance, here are a few. I think there's 5 here. So the first one, with a systematic sampling method, you'll just select every kth subject. An example of this, maybe you want to test gas mileage in people's cars. So what you do is every say 10th car that drives by, you stop them, you take a measurement, and then you let them go on. This may not be truly random because maybe every 10th car belongs to the same person, but this is one way of selecting a sample of people. The second way is perhaps the worst method, but the most practical. It's whatever sample is easiest. If you are going to be testing people on a college campus, you might just pick the first 10 people that walk by. convenience is convenient and practical, but often leads to worse results. A stratified sampling method is when you separate a population into strata, which is just a fancy word for different groups, different clusters, and you choose a sample from each group. One example of this, maybe you want to study a medicine, and you want to be careful because sometimes some medicines will affect men and women differently. So maybe you'll select a random sample of men and a random sample of women. The two strata in here would be men and women, and you would just choose a sample from each group. The next one, a cluster, is sort of the opposite of choosing a random sample from each strata. You just choose one cluster to do this with. So for example, if you wanted to study an American population, but you didn't want to bother selecting across all of the US, maybe you choose a zip code at random, and then you conduct your poll, your study, on just those people living in that zip code. This, again, will lead to some problems. Not when things are clustered, it's not necessarily going to be all that random, but again, out of convenience, maybe it's just easier to choose one group to study. And then a multistage sampling method is going to be some combination of some sampling methods. So for instance, maybe we do choose a random zip code, as in a random cluster, but once we have that, then we choose a simple random sample, as in just a random sample from that zip code. You can combine clusters and strata and convenience to create all sorts of different sampling methods. And I'll continue with the second half of section 3 in the next video.